Hi everyone! In this video, we will understand and interpret critical values. Carlos, a marketing director, believes the proportion of consumers preferring online shopping over in-store has changed from 70%. After conducting a survey, he obtains a test statistic of 2.33. If the critical values are negative 1.96 and 1.96, is there enough evidence to reject the null hypothesis? Let's go ahead and graph where we will find our critical values on a normal curve. Right down the middle will be the norm, and we are talking about proportion. So this middle is that the proportion equals 70% or 0.7. We have two critical values. One is 1.96 standard deviations below the proportion because it's negative, and the other is positive, so it'll be 1.96 standard deviations above. And so here's one standard deviation, here's two above, and one. So our critical values are not going to be quite as far out as the two. So 1.96 is going to be a little below. So our critical value cuts off right here. And negative 1.96 is going to cut off about right here, not quite out to 1.96 for the critical value, negative 1.96 for this critical value. Let's go ahead and identify what the null and alternative hypotheses are, just to help us keep this as organized and clear as possible. So we have the marketing director believes that the proportion of online shopping has changed. This means that it's not less, not greater, and we don't know if it's less or greater. So we're going to go for not equal to. Again, we're doing proportions, so it's a P, and has changed means it does not equal to 70% or 0.7. And a not equal to goes in the alternative. It will be either less than, greater than, or not equal to. So this is our alternative. That means that our null hypothesis is that the proportion equals what was already expected of the 70%. I also want to just point out quickly that our alternative hypothesis is not equal to, and to not be equal to something, you can be less than or greater than, which ends up being a two-tailed test, which is falling in accordance with this because we have two critical values, one lower, one higher. So our hypotheses are correct and our two-tailed test is correct. It's all exactly the same, and we have two critical values. So we've set everything up correctly. And now let's go ahead and graph our test statistic of 2.33. That's in the positive direction, so I know I'm going to go 2.33 standard deviations above. So I'm going to do this in red so we can see it. One standard deviation, two standard deviations, and it's not going to be quite 3. We'll make our third one here. 0.33 is going to be less than half, so let's put it right here. So this is our t-value or test statistic, and it is 2.33, which means it has definitely gone above our critical value. It has exceeded our line, our tolerance level, and so we would say, yeah, that definitely falls above, and we would then have enough evidence to reject the null hypothesis. As a reminder, the inside portion close to the average, the proportion, or whatever you're working with, right here is the fail to reject region. And so we've definitely exceeded that. So we can say there is enough evidence, there is sufficient evidence to reject the null hypothesis that the proportion equals 70%. We have now come to our conclusion if there is enough evidence or is not enough evidence to reject the null, and we're all done.